do I get that away? Huh. I don't want this on the bottom anymore. There we go. Okay. So let's estimate the initial, oh, geez, getting ahead of myself. The initial number of students infected would be P of 0. Can you see red okay? Which would be 100 over 1 plus e to the 3 minus 0, which is 100 over 1 plus e to the 3rd. Let me point this out. Sometimes AP would put something like this on a non-calculator and just have you leave your answer like that. Just so you can do as much as you can with what you know about E. Really the only thing at this point would be at day 3 that I could say, if I put day 3 in there, what would happen with E? No, it wouldn't. Well, the power would turn to 0. We'd have e to the 0. What's e to the 0? 1. And you need to know that you have to be able to write e to 0 as 1. If you need to write that down somewhere to remind you, I mean, you should know that. And then we could, oh, cool, that'd be cool. I could do 3 days without a calculator, couldn't I? Because then on the bottom I'd have 1 plus 1, which is 2, and 100 divided by 2 is 50.
Well, however, that question is asking how fast it's spreading, not how many people.
I'm not talking about B.
Oh. Snap. You guys are hilarious.
All right, what did we say this was?
4.74.
Which I would say we could say approximately, I would be comfortable, depending on how you want to think of this, with 4 students rounding down. Okay. All right. So this B is an excellent question because A is just a pre-calculus question. B is a calculus question. The question is, how fast is the flu spreading after 3 days?
Guessing it's derivative.
I'm guessing it's derivative because velocity isn't slope. It's the same as rate of change, right?
Yeah.
I'm just asking for the rate of change. It just happens to be it's the flu spreading. Very good. Here's how we write this. First of all, we want to avoid quotient rule at all costs. Why am I talking about quotient rule right now? Because I'm going to have to find the derivative. So would you guys help me out here? How would I rewrite this, Jarrett, Andrew? How would I rewrite this as a negative exponent instead? 100 what's on the bottom? 1 plus e to the 3 minus t to the what power? Negative 1 power. Okay, I did not do any calculus here. I'm simply rewriting this expression. Okay, do you see how we have 100 out in front? Don't include 100. We're not doing product rule here. 100 is just 100. It's a constant in the front. You have to include it in the derivative. Okay? All right, let's find the rate of change. I'm going to write this as dp over dt. So I put the 100 here because I need to do that. That's just a constant. How would I find the derivative of this? Don't freak out because it doesn't look nice. Okay, so I have negative 1. I'm putting it in parentheses just because I have it multiplied by 100 here. 1 plus e to the 3 minus t doesn't change. What do I put the power to now? The negative 2. And this is chain rule, meaning, Danny, I have to multiply by what?
Derivative.
The derivative of what's on the inside. What's the derivative of this? The derivative of e to the 3 minus t is e to the 3 minus t times negative 1. Okay, let me go through again. That's why I need no talking for your distraction and others' distraction. I brought the negative 1 down to the front. Does that make sense?
Yeah.
And I left the inside the same and reduced the power to but then this involves chain rule, because what's inside is not just an x or a t. So I took the derivative of this function. The derivative of 1 is just 0, so I didn't include it. The derivative of e to the whatever power is itself, but then if it's got another derivative in the top, I have to multiply by that. Isn't the derivative of 3 minus 2 negative 1? Okay, that's why I did that. It's like chain rule.
It's like triple chain rule. It's 2 chains rule.
All right.
Got that on record.
I think that we can do this without it is recording. All gonna be. So if you want to relive class and laugh a little, or maybe not.
Look at it in like 5 years, like, was that annoying?
Yeah.
Okay, let's move along so people who do watch this video later don't have to listen to our banter. All right, what goes on top, what goes on bottom, guys? This is good practice. This goes on top, this goes on top, this goes on top, this goes on top. Oh, cool. So that goes on the bottom, correct? All right, here we go. We have 100 times negative 1 times negative 1. That's easy. That's 100. E to the 3 minus t on top. On the bottom, I have 1 plus e to the 3 minus t squared. All right, any questions on that? Have I answered the question that B asked? No, it said, now it has the rate of change, but did I evaluate at 3 days? Let's do that. We can do this all without a calculator. E to the 3 minus 3 is e to the 0, correct? What's e to the 0? So what is the top? 100 times 1, or 100. Okay. On the bottom, e to the 3 minus 3 is e to the 0, which is 1. So I have 1 plus 1, which is 2, but then I have to square it, which is 4. What's 100 divided by 4? Okay, now, units are important here. 25 what?
People per day.
Students per day. Now that's not how many are infected, that is how much it is, how fast it's spreading. So 25 more people per day than we're getting infected per day. See what I'm saying? Okay, I will tell you this, and we'll draw this conclusion in a second, but this means what I was finding here was the slope of the graph, and here's my graph. I'm finding the slope at 3. So if I go back down to 3, okay, there's 3. That 25 just means that line has a slope of 25 right there. Does that make sense graphically? Okay. Now, C, to answer C, right now we have to use our calculator to do, and so I will not ask you to do that without a calculator. We want to find when this has a maximum. So here's what we're going to do. We are going to graph dp dt and find its maximum.
Find the derive that and then find the zeros.
At this point, I have told you that, but you don't know that yet.
Well, okay.
That's called the first and second derivative test, and we will learn about that more second chapter. Yeah.
So finding the maximum, deriving.
Well, and then you have to make sure that you're finding a maximum isn't just necessarily the 0, because it could also a 0 could also be a minimum. So you have to then find where is it switching from negative to positive and positive to negative. We are going to spend oodles and oodles of time on that. All right, here we go. 100, I'm graphing this right now. Oops, I got to use some parentheses. 100, practice this, guys, because if I ask this on a test, people often screw up the parentheses. So 3 minus x, and that is just around the 3 minus t right there. So I need another parentheses, divided by 1 plus e to the 3 minus x, close the parentheses, squared. Hey, look at that. It's got a maximum. Okay. Can you guys find it for me? Any guesses? It's the same. Well, okay, so when we found its maximum, did you get x equals 3, y equals 25? Yeah, that's not a mistake. I mean, it is t equals 3, okay, at time equals 3, and I'm going to label that in, what's my label here? Look at the question. 3 days. And what was our rate of growth? We already answered that above. 25 students per day. It was changing. That's how it was changing. That's how the growth was changing. It doesn't mean that's how many were expected per day. Okay. And really think about that on the logistic curve. It's level, right? And then it's steep and then it levels off. In the middle of that steepness, wouldn't that be the fastest rate of change? And it always does happen to be at the 0 there. So when we deal a little bit more later in the year with some logistic functions, we'll talk about that again.
So can we find the maximum by also finding the 0 at the center?
At this, with that kind of equation, yes.
Okay.
All right. How did that go, guys? Questions? Comments?